Chapter 9, section 9.1, algebra of the function or composite functions. When you have equations of a straight line, which normally is like y equal ax plus b, or let's say example y equal x plus 1, because the first degree, the power of x is 1, this is equation of a straight line. Now, you see here that variable of y depend on x. So sometimes instead of just showing the y, we just say f of x. F of x and y are the same thing. The only difference is when you write f of x, that means you have a variable of x. So if you have f of a equal 2a plus 3, that means you have the equation of y equal 2a plus 3. Means your variable is letter of a instead of x. So f of something just tell you that your letter is a or x or anything else. But again, f of x and y are the same things. So when I say here x is 3 in this equation and find a 1 to find a y, if you take the 3 and put it here, 3 plus 1 is 4. So you say y is 4. Or when you say what is f of 3, what is f of 3 means here you just write y equal f of x equal x plus 1. F of 3 basically means when x is 3, what is the value of y? Okay, so f of 3 equal 5. So remember, f of 3 and f of 3 is y means y equal to 4. So if you have the functions of f of x is equal to, let's say, 3x plus 5, and we ask you to find f of 2, f of 2 means take 2 and substitute for the x here in these equations. So it would be 3 times 2 plus 5, or 11. So now here, you could take two different functions and add it together, subtract, multiplication, and so on. These two functions is given. F of x is x minus 1 and g of x equal to x. So we use letter of f and g to tell you that these two functions are not the same thing. How do I add these two functions? F plus g of x means just take these two and add together. They show you here. F minus g of x means f of x minus g of x. See, f minus g of x means f of x minus g of x. When it comes to subtraction, just be very careful when you do the subtractions. Make sure you put a parenthesis first, because of the subtraction, that negative would change the sign here. F multiply gx, f multiply gx means f of x times g of x. So that means you just take these two fractions, take these two and multiply. And again, ratio of f over gx means divide these two. Now, next is you have composite functions. Composite functions, okay? So let's say I have two functions. I want to find, I have these two functions. F of x is, we'll just do this one, x2, and g of x is x plus 3. I have two different functions, okay? What does f o g x means? This is composite function, because you could actually take two functions and combine. FOG of x, you could write it as f of gx. We write it like that because g is closer to x than f, right? Now, gx is x plus 3, okay? So instead of gx, you put x plus 3 here. So now you have f of x plus 3. Now, what does f of x plus 3 means? You understand that f of x equal to x2. What if I ask you to find f of 1? F of 1 means take 1 and substitute for the x. So it would be 1 to the power of 2 is 1. What does f of letter A means? It doesn't matter what you have in the parentheses, whether it's a number or a letter, you take this and you substitute for the x. So what does f of A means? A to the power of 2. Now, what does f of x plus 3 means? Again, regardless what you have in the parentheses, you take that and you substitute for the x, not for x2, for x. So now is x plus 3 to the power of 2. Okay, so finally, f of x plus 3, the answer is x plus 3 to the power of, that's the composite function. Now, it's easier with the numbers, like here, what is FOG of 2? What is FOG of 2? Again, G is closer to this number, right? So you could write it as F of G2. So you gotta do that first. G of 2, you go to the G functions. G function is what? Is G of x is x plus 3. You need to find G of 2. So G of 2 is 2 plus 3 is 5. So G of 2 is 5, means now instead of G of 2, you put 5. Now what you have? Now you have f of 5, means go to f functions and put 5 for x, because you need to find f of 5. F of 5 means go to f functions and put 5 for this x. So it would be 25. So the whole thing would be 25. So what is FOG of 2? 25. And it's different, like why FOG of 2 and GOF of 2 is different, because this one, F is closer to 2. So you have to do F of 2 first and then find the other one. Based on that, there are some homework assignment here. This one, you're just adding all this. These are just addition and subtraction. So I put some example for you to hear. And these are the answers. But don't look at the answer first, try to do it yourself. FOG of 5. Okay. What does FOG of 5 means? Again, G is closer to 5, so that means F of G5. F of G5. G, you have to find G5 first. You go to G functions and you put 5 for x. So that would be what? Minus 25, right? So you take this minus 25 and you put here. So now you have f of negative 25. How do you find f of negative 25? Go to fx and put negative 25 there. So I show you for all these problems, you have the solution here, so you can take a look. These problems are all very similar. So that brings us to section 9.2. 9.2, we are talking about one-to-one function or inverse functions. What is one-to-one function and what is inverse functions? Okay. Now, let's look at this graph here. If you have a line like this one, and when we ask you to find inverse function, what does inverse function means? Okay, so I want to work on that one here for you. On the previous section, we talked about what is one-to-one functions. If you have a functions like this, okay, this function, there are two tests that determine whether your functions, your graph, whether your graph is one-to-one or not. To see if your graph is one-to-one, that graph has to pass two tests. Okay, one test, they call it horizontal test. Horizontal test means you cut a straight line and you start from the top and you lower it like this. If that line intersect the graph at only one point, see, when you draw the horizontal line, intersect the graph at just 1 point, right? And then you do another one, 1 point, right? 1 point. So this graph pass horizontal test. Passing horizontal test means your graph must intersect the horizontal line at only 1 point. Now let's look at another one. Now this one, does it pass? No, because when you have a horizontal line, look, your horizontal line intersect your graph at 2 points. So this one fail horizontal test. And then let's look at another one. This graph, it passed the horizontal test. See, it just intersect at 1 point. That's fine. Now, one-to-one functions must pass horizontal and vertical test, both of them. See, must pass both of them. Means if you bring the vertical line here, that vertical line also cross at 1 point, you see? So this is one-to-one functions. Like this one, it passed the horizontal test, right? But it failed the vertical test. Look, when you draw the vertical line, it intersect at 2 points. So this one failed, and that's one. This one passed the vertical test. Look, if you draw the vertical line, it passed the vertical, but it failed the horizontal. So one-to-one function is a function that passes horizontal and vertical test, okay? So when you have a straight line, like this, This line, which is, what's the equation? Y equal to 3x minus 5. This line passed the horizontal test and also the vertical test. Okay, so this is one-to-one functions. Now, all the one-to-one functions, they have inverse functions. Now we want to define the inverse functions. So to have the inverse functions, first you need to have one-to-one functions. So this line, equation of this line is one-to-one. So therefore it does have the inverse functions. There are two ways to find the inverse functions. One is by algebra. By algebra means you write your functions. The first thing you do is you switch x and y. You swap x and y. So you put x in here and y on the other side. Now you want to write y in terms of x. So you want to isolate y, right? So you just say x plus 5 is equal to 3y. And then divide both sides by 3. So y equal x plus 5 over 3. This is your inverse functions. And remember, for y, we just show f of x. What symbol do we use for inverse functions? Is like this. You have the -1 at the top. That's what the inverse function means. Okay, so if you have the function of f of x, and you know this function is one-to-one, to calculate the inverse, which is this, you have to swap x and y first, switch these two, and then write y in terms of x. This is the inverse functions by algebra. If you want to do it graphically, how would you graphically? To do it graphically, first, you have to draw a line that intersects this angle. You know, this angle is 90 degrees, right? This is 90 degrees. Bisector of this angle is a line that split this into 245. So you got to draw that first. Then you find reflection of this line with respect to that. Means every point on this, you draw the vertical line, extended the same distance. The same distance. By doing that, you come up with a new line. That line, which is this one, in these equations. Okay, so now I show you that in the better graph here. See that? This is your bisector, okay? You see this point? When you find reflection of this point, or you draw the line, extended the same distance to find this one. Then this one, you draw the vertical line, you extended the same distance, give you these new lines that you have here. This is your inverse functions by method of graphing. So if we ask you to find it graphically, this yellow line, which is f of x equals 3x minus 5, if we ask you to find inverse of this by method of graphing, you draw a bisector first, and then image of this with respect to this line is this is like flipped it. Okay. See, it's like this line. When you find the image of this with respect to that is this. That is inverse functions. See here? This was the original one, for instance, right? I'm sorry, this one was the original one, right? You see that f? Reflection of this with respect to that is this. They show you some pictures here so you could tell, you know, like this is the f of x. Reflection of that is this. This is f of -1. This is f of -1. F of -1. So this is f and f of -1. And then there are some examples here. Again, look, to find the inverse functions. So here, I'll show you some problems here. They have these functions, f of x equal x3 plus 3, right? They want us to find, first they want us to find f of 4. You know, f of 4 means just take the 4 and substitute for the x. Okay, so if you have f of x is x3 plus 3, how do I find f of 4? F of 4 just means take the 4 and substitute for the x. So it would be like 67, right? Then they ask you to find, this means what? This means find the inverse functions, which is f -1, and then put 67 inside of that. Okay, so what I need to do is first, I need to find the inverse function here. To find the inverse function, first I switch x and y, okay? Then I write y in terms of x. This is your inverse functions because y is written in terms of x. So in this one, if this is your inverse function, so in this inverse functions, now when they say find f -1 of 60, that means take this 67 and put it into this function for x. That's what I did here. Okay? Like the second one is like that too. Look, this is your functions, right? They say find f of -3. F of -3 just means take this -3, go to f function, take this -3 and substitute for x. But f -1 minus 20 means find the inverse function first, and when you find that function, then take -20 and substitute there. And that's what you have on this one. See, you have to find it first. When you find it here, then take this -2 and substitute there. And this is how to do the graphing. Remember, this one is x plus 3. You graph that first. This is your f of x. I'm sorry, this is your f of x. Let me just write it here so we know. And how do you find this one? You draw if you draw the bisector, and what is image of this to this bisector is that one. Okay. And I'll show you. So what I did was, this is your functions, right? I switch x and y. I solve this too. This is your inverse functions. So what you could do, you could just go ahead and graph this one and that one separately. See, this is your f of x. And this one is your f of, this is your inverse function and this is your actual functions. You could graph it separately. Same thing here. F of x equal to x plus 5. I show you how to graph that, but just plug in 2 or 3 points. So that would be your f of x. And then we ask you to graph inverse. Okay, what you could do, you could find the inverse first by switching x and y. So this is your f of x. You're switching these two. This is your inverse function. So you have two graphs. The regular functions and the inverse function. You could, when you graph this, you see that. And remember, if you want to do it graphically, the bisector has to go through this point. Remember, this is a bisector of the line. So you should have something like this here. You should have this bisector here. So these are all very similar. These are just a different practice of how to find the inverse function. Now we go to the last section, 9.3. This is the last section. 9.3 is talking about graphing exponential functions. All the functions that we have been doing so far, they all was like this. Look, y equal x plus 1, y equal like x2 minus 3, y equal like 5x3 minus 1. They all have power is the number, right? You see, the power is 1, power is 2, power is 3. What if the power is the variable like this? You see, I want to show you the difference between these two. The difference is this one, exponent is the number. This one, exponent is the variable, but base is a number. This, they call it exponential functions. Exponential functions. So exponential functions is a function that base is a number and power is a variable. And it's very similar as far as the graphing, like this one. You remember how you put some x and y here for that? You do the same thing here too. So they all, b could be a number, but make sure that b is greater than 0. It has to be like, a number like 1, 2, 3, 4, so on. And these are some examples. See, 2 to the power of x, 3 to the power of x. One nice thing about exponential function is most of them look very similar. Look. And they all are one-to-one functions. See this one? If you have the horizontal line and the vertical line intersect the graph at only one point. So this is a y-intercept. How do you find the y-intercept? Regardless what the base is, if you put a 0 for x, b to the power of 0 is always 1. So this 0, 1, which is the y-intercept, basically works for most of this problem. You see that? Because when you have any number to the power of x, okay, when x is 0, when you put 0 here, what is 2 to the power of 0? If you use your calculator, any number to the power of 0 is always 1. Like on this one, when you put 0, what is 5 to the power of 0? Use your calculator, 1, 1, 1. So it doesn't matter what the base is, right? If the base is a number, when you put 0 for intercept or y-intercept, you always get 1 for y. That's why they have it here, 0 and 1 for y-intercept. And like to graph this one, why we call it exponential function? Because the base is the number and power is a variable. You just put all these numbers, that's how the graph looks. These are all similar, okay? And so I'll show you how to just go ahead and put some numbers here for all this. These are not that hard to do. Then you got this type. How do I solve these equations? 4 to the power of x. 16 is what? 16 is 4 to the power of 2. See, in this case, if these two sides are equal, x has to be 2. Right? 4 to the power of which? 4 to the power of which number is 16? 4 to the power of which number is 16? 2, right? So that's how you find it. For here, 243 is I broke that one here. So this is one way to do it, or 243 would be 3 to the power of 6 to the power of x, and 9 is 3 to the power of 2. And in algebra, if you have more than one power, you always multiply, right? So 3 to the power of 6x is 3 to the power of 2. 6x is equal to that. Is it 6 or 5? I'm sorry, this is 5. So 5x equal to 2, and x is 2. That's another way to do it. What I did here was this. There is a formula in the log that We don't really have to deal with it, but that is if you have the log of a to power of b, b can always be transferred here, but I don't think so that's necessary. I think that's what they want you to do. I want to show a different solution, but here, the best thing is take 243 and break it. So that would make it 3 to power of 5. 3 to power of 5 is 243. So, and then if you have more than one exponent, so if you have this rule that if you have more than, yeah, we had this formula. If you have more than one exponent, you always multiply the exponent, nm. So if I have like 3 to power of 5 to power of x, 2 power, right? So it would be 3 to power of 5x. That's the formula that we had in beginning of the algebra. So we use that one here. So that would be 3 to power of 5x equal to 3 to power of 2. Now, if both bases are equal, you always set the exponent. So 5x equal to 2x is 2/2. See here the same thing. 16 is 2 to power of 4. Is that 2 to power of 4? You have more than 2 power, right? You multiply these two. On this side, you have 2 to power of 1. This side, you have 2 to power of. So to have these two sides equal, the power must be equal. This one must be equal to 1, both power. And that gives you the value of x. This is an easy one. 9 is 3 to power of 2. 27 is 3 to power of 3. You have more than one power, you multiply that. 2x is 3x is 3/2. Same thing, 81 is, bracket is, 81 is 3 to power of 4, okay? You have more than one exponent, you multiply these two. On that side, 9 is 3 to power of 2. Bases are equal, then you set these two equal to each other to find your x. Same thing for the last one too. Okay, same thing. All right, so that would be end of chapter 9.